Hello and welcome to today's lesson where we're going to look at the density of an irregular object which falls into the particle model of matter topic in GCSE Separate Science Physics. So in today's lesson we're going to look at how to calculate the density of an irregular shaped object, which is a required practical for GCSE Separate Science Physics. So if we're successful and we learn in today's lesson, we can be able to accurately collect mass and volume readings for irregular shaped objects. We can draw a bar chart of density for irregular shaped objects and analyze data taken for density measurements for irregular shaped objects, which falls into the following part of the AQA GCSE Separate Science Specification for Physics, required practical 5, using the appropriate apparatus to make and record their measurements to determine the density of irregular solid objects. So in our investigation today, your aim is to find the density of different irregularly shaped objects. So what you would need is the following: a top pan balance, a 400ml beaker, a 100ml measuring cylinder and materials to use. So to start off, you would take an empty 400ml or 400 centimeters cubed beaker. You'd fill this with 200 centimeters cubed of water, which is the volume before the experiment. Now you gently place a piece of material in the water and record the new volume in the beaker. This is the volume after in the investigation. You subtract the volume before from the volume after to find the volume of the material. You then remove the material from the beaker and place this on an electronic balance to find the mass of the material. You can then calculate the density by doing density equals mass over volume, and you repeat this for different materials. So you would get a balance and ensure the balance is zeroed. If the balance reads a non-zero value when there's nothing on it, it has a zero error. Now a zero error is an example of a systematic error. This is when there's an error of the same value in each measurement. So the value of the error is the same for each measurement that you would take in the investigation. Now to remove a zero error, you either subtract the value from the reading or you reset the balance. Now the different balances can have different resolutions. Remember, you would record the results of the mass to the resolution of the balance used. You would then get a 400ml or 400 centimeter cube beaker, and then you would place 200 mils of water from the tap into the beaker. Now ensure the water is flat along the 200ml line. Now you've got to look straight on when you're measuring this value, otherwise you would gain what we call a parallax error. Now a parallax error is an example of a random error in science, as in each measurement the value of the error is different each time. Now a random error can be reduced in science by taking repeats and averaging the values. You would then retrieve a material stated in your non-symmetrical or irregularly shaped object table. You would then place that material on the balance and measure its mass. Remember to record the mass to the same no decimal places as given on the balance. You recorded the resolution of the measuring device, and then you place the material in the 400ml beaker of water. This will cause the water level of the water to rise in the beaker. You've got to obviously be careful placing the material in the beaker or the beaker may crack. Now you'd measure the new volume of the water with the material in it. Now remember, ensure the water is flat and you look straight on when measuring this value, otherwise you would gain a parallax error. Now you may have to estimate the value due to the large differences in between the markings on these particular beakers. Now you can then use that to derive the volume of the material. The volume of the material is equal to the final volume minus the starting volume, and you can then calculate the density of the material using the equation density is equal to mass over volume. But remember to give your answer to the same number of decimal places as the mass and the volume measurements. Now when you're carrying this out, remember, okay, you've got to know what each material is. Now for wax and wood, they are stuck down into the beakers as they float, so you'd need to pour water into the beaker. So for this particular investigation, you would, to measure out the 200 mils, you would measure it out in a measuring cylinder first and then pour this into the beaker. So you would have to do that for wood and you'd have to do it for wax. Now make sure when you're doing these particular items you place them inside the water and you measure the volume difference from the start to the end once this has taken place. So you've got things like rubber, you've got glass, you've got coal, you've got steel, you've got aluminium, you've got a rock, you've got all those different materials. Now you would then fill in your observations in the following table, so you can work out the mass of the material by using the balance. You know the volume before would always in this investigation be 200 centimeters cubed. You can then measure the volume after, then you can work out the volume of the material because it's the difference in the volume measurements, because that's how much water has been displaced, the volume of the material, and then the density is equal to the mass of the material divided by the volume. Now once again note that the mass of the material is in grams and the volume of the material is in centimeters cubed, so the density is in grams per centimeters cubed because the density unit is the unit of the mass divided by the unit of the volume. You would then draw a bar chart of your experimental results, placing the density on the y-axis and the material on the x-axis. Always include a label and unit on each axis, and you will get graphs such as this for your experimental results. So what should you be able to do in this particular investigation? You should be able to use appropriate apparatus to make and record measurements needed to determine the density of irregular solid objects. Now in this investigation, volume should be determined by the displacement technique of the idea of the volume increasing when an object is placed into it. Now if you've been successful and you've learned in today's lesson, you should be able to accurately collect the mass and volume readings for irregular objects, draw a bar chart of density for irregular objects, and analyze the data taken from the density measurements for irregular shaped objects. I hope you've enjoyed today's lesson where we've looked at working out the density of an irregular object. Thank you very much and have a lovely day.